Good. Hi, folks. I'm Thomas Edwards. I'm a Senior Manager Solutions Architect at Amazon Web Services in the Media and Entertainment, Games, and Sports Group. This presentation was actually originally put together by an SA who reports to me, Brian Samus. Super intelligent guy. He's so smart that right now he's in Puerto Vallarta, Mexico on PTO. Thus, I will be the voice of this presentation, so please bear with me. I'll also say that the market, the global market for cloud service providers is global and competitive, and I will be talking a lot about AWS today. Obviously, we have competitors. Please check them out. But unfortunately, I can't really speak for them, so this is a primarily AWS cloud-oriented security discussion. And ahead. Okay. Werner Vogels, our Chief Technology Officer, has made it clear that security is our top priority, and it should be your top priority as well. Protecting your customers should always be your #1 priority, especially in media and entertainment, where we have incredibly expensive rights for the material that we're putting on the air, and also trying to make lots of money from the advertising or betting or however you're monetizing your content. Within AWS, we like to refer to a shared responsibility model where AWS is responsible for security of the cloud. So that's security of the data centers, the hardware, the network cabling, things along those lines. And customers are generally responsible for security in the cloud, which is their choice of AWS cloud services and how they actually utilize those services. Now, depending on which AWS service you're using, the line varies. If you just have an EC2 instance, which is virtual compute instance, AWS is responsible for the data center, the hardware, the cabling, things like operating systems, applications, client data. That's all customer responsibility. We have some things we call container services where AWS takes a bit more responsibility. For instance, in RDS, our database service, we take responsibility for the operating system as well as some of the application. But again, some of the things above that, network, access control lists and encryption, customer data, again, that's on the customer. And for our most abstracted services like S3 storage, AWS takes responsibility for almost everything except for, of course, the actual data that the customer has. AWS is a wide range of security, identity, and compliance solutions in identity access management, detection of threats and events, infrastructure protection, data protection, and incident response. And we could have a 6-hour-long discussion about all of these. If you want, you can even go out there and take the AWS Certified Security Specialty course, but we don't have time for that today. So let's just talk about live cloud production. And this presentation was developed by Brian. It basically is kind of a series of thoughts that he had about what he's running into as he's working with our customers doing live cloud production. And we know it's gaining in popularity. We know that Tier 1, the most high-level sports productions, they deal with components from many different vendors put together in very complex environments. And the question is, how can you secure that on the cloud? Lots of live cloud production out there going on. Sky Sports Netball, European League of Football, La Liga Pro C, the kind of third-tier football in Italy. A lot of these are being done with either single vendor or they might be a single vendor SaaS even. But when you connect multiple vendors together, like what we did for the NHL Network for their broadcasts of a hockey game last year, we're dealing with a lot of stuff going on. JPEG XS streams coming in. We've got Dante audio. We've got a mixture of various VDIs such as Nice DCV, virtual desktop. We've got NDI high bandwidth. We've got an NDI HX. We may be even splitting off a couple SRT streams for some people taking the game. More Dante audio, more et cetera. So it's complex. There's a lot going on here. It's challenging to secure, and you have to be careful. Whenever we're architecting workloads on Amazon Web Services, our touchstone is the AWS well-architected framework. And within the well-architected framework, we have a number of different pillars. Some of them are how you are efficiently using your system, how you're being resilient, and one is security. And this is really what we go back to time and time again to make sure that we're doing a well-architected workflow with our customers that meets all of the security requirements. So there are a bunch of challenges specific to live cloud production, including securing the infrastructure, securing the applications, and securing the audio and video protocols which we're using to move media around either from ground to cloud, cloud, or cloud back to ground. And also there's satisfying your corporate IT staff, which can be almost as challenging. So let's talk about infrastructure. So security best practices are to frequently update your systems with security patches. Now, the big challenge is, can we update the critical on-air infrastructure? And if so, how often can we do it? And when, in what windows can we do it? What testing is required to make sure that after we do those patches that we feel comfortable and confident about the system? We need vendors to provide and bless these updates. And we have a challenge of balancing a good security posture with the fact that often we need to do 24/7 seamless operations. So some of the common security agents you may find out there, such as antivirus or some endpoint security management systems, can interfere with real-time operation, and they need to be cautiously applied and tested to see if they are going to be compatible with your real-time media services. And we also get vendors that sometimes ship software as machine images, but they may be running on outdated operating systems. And vendors sometimes do not allow modifications or access to the underlying operating system of the virtual images which they ship. Has anyone seen something like this? Raise your hand if you've seen something like this what about in the last week? Okay, so we're improving, I see. Has anyone seen something like this in the last week? Okay. We know this is not best practices for application access, right? We know that there are some broadcast applications out there that do not follow the IT best practices. They use unencrypted protocol for logins. They don't support single sign-on and multi-factor authentication. And these YubiKeys down there are a great way of providing multi-factor authentication. They do not enforce credential complexity or rotation, password, no. And sometimes you'll find workflows that involve credential sharing or reuse. Everybody in the room's got the same password to the system that they have to walk over and utilize. Again, not best practices. Now, we do believe you do need to balance the right authentication for the purpose. So if you're in a master control, there's a monitoring system, maybe it doesn't need to auto lock out every 5 minutes. Maybe it can be on, and maybe even a couple of people can share some credentials for that if it doesn't break anything. If you have a system that can break something, you do want to have very secure authentication into that system. So just be aware of that balance. We have some challenges with audio-video protocols. For instance, I'm going to call out NDI for requiring ports 5960 and up, so 60,000 ports need to be opened in order to use that. And we see other ones that I won't mention having similar challenges with that, right? It's a lot of open holes in your firewall or security groups. Now, are these challenges unique to the cloud? Often not. Some of these same threats exist in your on-premises system, but they may have less scrutiny because it's actually harder to figure out what's in an on-premises system when it's just sitting there and you can't really inspect it with an API. Broadcast applications often exist in this island that's not subject to corporate IT audits or compliance. And SaaS services, that's great, but you still have a single vendor that needs to architect that SaaS securely. So, as customers move to the cloud, IT departments are beginning to really enforce compliance with security best practices, vulnerability scanning, least privilege access, network firewalls, and because it is on the cloud, it's very easy to use an API and figure out exactly how many servers, how many storage buckets, what type of network firewalls you've set up. So it's easy for your corporate IT to actually figure out what you're doing. You can't hide like you could in your on-premises data broadcast center. But although it is possible, if you'd like to build a virtual private cloud environment that's completely isolated, as much as your on-prem system, you can actually build something like that, but it might not be very useful. So now I'm going to address the broadcast vendors in the room, which is almost all of you. We all need to take a better job of taking security seriously. We've got vendors shipping software images on old, unsupported operating systems. Brian was pointing out he saw something with Ubuntu 18 that went end of support in 2023. He saw something with CentOS 7 that went end of support and stopped receiving updates last year. So, if an urgent zero-day security vulnerability patch is released, we find broadcast vendors a little bit slow to validate and test the patches with software. And we recognize that sometimes broadcast vendors have these slow software release cycles. But IT departments might require critical patches to be immediately applied within days, or worst case, or if you're lucky, just weeks. And my suggestion is for vendors to take a look at automated testing techniques to try to speed up the releases. When the patches come in, run the automated testing. It may take a few hours to go through all the different video switching, audio consoles, graphics insertion, but to try to have that automated as much as possible so you can quickly respond to these security threats. And we know vendors are very challenged because also each customer has their own IT compliance and security requirements. And sometimes these are different from each other, depending on which customer you have. And we think there might be some opportunities to form a set of best practices that customers might be able to accept within the media and entertainment space. I know the European Broadcasting Union is a bit ahead on this with R143, their cybersecurity recommendation for media vendors, and their R160, the vulnerability management for media companies and media system vendors. So these are perhaps good documents to take a look at. I know they're also potentially forming a new security organization as well. So this might be an opportunity for multiple M&E customers to try to get on the same page when it comes to their IT security requirements. So you might ask the question, well, AWS has a lot of media services. We're a vendor too for our elemental services, for instance. How do we handle this problem? So AWS elemental media services need to be highly available, but also compliant with AWS's incredibly stringent security requirements. As someone who manages 4 SAs, I can tell you every week I get an automated email from a testing system saying, oh, Brian just did this thing. He left a port open somewhere. We automatically close the port, but don't do it again, right? So we've got a very strict system. And we know we need to be able to still be able to be a real broadcast vendor and get our products out there. So our Media Live encoder and our Media Connect kind of IP distribution amplifier in the cloud are both built with a concept of channel maintenance. So if we get an operating system or application software needs to be updated, customers are sent an email, or they can see this also on their personal health dashboard, that their channel is due for maintenance. And then the customer can accept the default maintenance window if it meets their schedule, or they might be able to manually schedule a preferred time for that maintenance on that channel to occur. And then the channel will automatically restart to apply the required updates within that maintenance window. For systems like Media Live that have 2 pipelines, or standard channels, they're set up so they can be restarted 1 pipeline at a time. So if you have downstream failover, it can actually restart 1 channel, and you go failover to the other channel, and then restart the other channel, and then it fails back over to the other one. So you actually can have an update without losing any performance. So whenever channels start, they start with the latest updates and patches automatically applied. So in this case, if you're just doing, let's say, live cloud production of a game, where you're just up for a few hours and then you go back down, when you bring it back up again for the next game, it'll come up with all the patches applied. If you're doing a 24/7 operation like playout, that's a little bit more challenging. In that case, you do need to schedule the maintenance at some point and have some type of failover mechanism so you can stay on the air. Customers can opt to manually restart the channel at their convenience to get latest updates rather than just waiting for the default maintenance window. And, it's not perfect, right? This still requires some scheduled interruption that's either going to reduce your output, or is going to reduce your resiliency, or you may have to make arrangements to have another channel come up. But it does seem to work. And it ensures that AWS Media Services are always up to date with the latest security patches, software updates, and drivers, etc. Best practices. I need to tell you about a few AWS services so that you'll understand what these best practices are all about. AWS Systems Manager allows you to manage a large number of EC2 instances as well as on-premises servers if you want to securely at scale. It helps you connect to those nodes using an out-of-band mechanism, so you don't have to worry about opening up inbound ports, you don't have to set up Bastion hosts, or you don't have to manage SSH keys, which of course makes this all a lot more secure because it's completely out of band. You can automate any operational commands at scale, like if you need to do security updates on 100 EC2 instances, you can use Systems Manager for this. It also gives you visibility across your entire fleet. So you can look for if there's any patches which need to be done and haven't been done, if there are systems having problems or anything along those lines, Systems Manager can help you there. It also has a parameter store. So this is a good place for storing passwords or database strings, license codes, either as plain text or preferably as encrypted data. And that parameter store can reference Systems Manager for automated workflows, as well as using Secrets Manager for secrets rotation. And that brings us to AWS Secrets Manager, which allows you to rotate, manage, and retrieve database credentials, API keys, license keys, or any secrets that you need through their life cycle. You can either go in through the console and get them directly, or they're also accessible via API, so your software can call out to the API to get secrets out of Secrets Manager. AWS Identity and Access Management is what provides the fine-grained access control to specific AWS service APIs and resources. We have IAM users who can sign in with credentials and authenticate to AWS. What's probably more useful is IAM roles, and these are taken on by various services and can provide short-term credentials for users, workloads, or AWS services to perform various actions within your AWS account. And finally, there's security groups, and you can think of these like virtual firewalls that can control inbound and outbound traffic to every single EC2 instance. Each instance has a security group. So you should run up-to-date operating systems with the latest security patches applied, and you can use AWS Systems Manager to automatically alert you to any non-compliant resources that need to be patched and make them patched. You can use infrastructure as code to have a repeatable architecture. So you may be building architecture for one game, and then you want to use that same architecture on the next game. rather than have someone come in with a mouse and go into the AWS console, it's a lot better to create infrastructure as code, either through CloudFormation, the Cloud Development Kit, or Terraform, which allows you to be repeatable. You can even do it between customers to some extent as well. You should apply the least privileged access principle. So assign EC2 instances the minimum required IAM role permissions which are needed for their specific function, right? If an EC2 instance only needs to read from one S3 bucket, scope it to just that S3 bucket. It can't touch any other S3 buckets, and just read from that S3 bucket instead of being able to write to it. The fine-grained control of IAM allows you to really tighten up on least access privilege. You can use condition statements in IAM policies to further restrict it by IP range, by time of day. Like this EC2 instance should only be doing something between 10 a.m. and 11 a.m., and the rest of the time it shouldn't be doing anything. You should place EC2 instances in private subnets where they're not accessible via the internet unless internet access is explicitly required. You should configure security groups and subnet network access control lists to allow only the necessary ports and protocols from specific sources or IP addresses. So for instance, only allow SSH from a Bastion host, or only allow SRT traffic from a contribution encoder. You should not allow direct access to SSH RDP over the internet. Please use System Manager as an out-of-bound way of connecting to your EC2 instances, or worst case scenario, use a Bastion or jump box, preferably with single sign-on, multi-factor authentication, and don't use passwords, use SSH keys, which are much safer. And if you don't know what a Bastion host is, this is a quick architecture diagram. You have a Bastion host, which is in a public subnet accessible via the internet, where you can SSH or RDP into it, and then from that Bastion host, you can then SSH and RDP into a private subnet, thus keeping that private subnet from being attacked from the global internet. Now, of course, if someone does break into your Bastion host, then you could have a problem if they know your SSH key to go into your private subnet, but at least it's one more step an attacker has to go through. So for infrastructure, for real-time complex environments like live cloud production, software updates and patches might require extensive testing by both the customer and the vendor and your own teams before being used on air. And you should establish an update cadence to properly test and be confident in those updates before applying them while still maintaining a reasonable security posture. I was talking with one customer in here, and the customer said, oh, it's about 2 weeks of testing after we do the patch before we feel confident taking it to air. So that's the kind of level that we see out there. Depending on the nature of your business, your production schedule, the patches could occur monthly, they might occur quarterly, biannually, or even annually, but it depends on your risk acceptance and your compliance requirements. Never store credentials directly in software in your instance. Utilize IAM roles and tools like AWS Secrets Manager or Parameter Store to securely store those credentials. For operator access, please change the default passwords. No password. Each operator should have their own credentials. Operators should use an approved password manager to store the credentials, as opposed to the little scrap of paper or the Excel spreadsheet. Use single sign-on or multi-factor authentication where possible. Only allow access to application from trusted networks. So use host firewalls, security groups to restrict access to admin interfaces or APIs. Allow operator access only from a corporate network or from a VPN, not from the global internet, unless your workflow specifically requires that. preferably a VPN, though, if you have to have long-distance access. Enable encryption in transit if your application supports it, such as HTTPS. For virtual desktop access, use protocols that support encryption in transit. Nice DCV is one, which uses HTTPS, TLS, or even RDP uses RC4. For audio-video protocols, which require a range of open ports like NDI or Dante, we recommend the use of a self-referential security group. What this means is that EC2 instances that have the security group can talk to other EC2 instances that have that security group if it's self-referential. So you could create a security group called NDI traffic, which has an ingress rule to allow all traffic in the required range of ports in that security group called NDI traffic, and then you can apply that security group to other EC2 instances in your VPC that need to send or receive NDI traffic. But specifically because it's a self-referential security group, only instances that are part of your NDI network can access NDI ports on your system. And for protocols like SRT, which are generally ground to cloud or cloud to ground, you can create selective security groups to only allow traffic from the expected source and the expected port. So and you can also use SRT password encryption if needed as well. To detect security threats, we recommend the use of AWS CloudTrail, which will track all user activity and any API calls for AWS services. And also, you can use VPC flow logs. You can record the flows of any network interface in a VPC, or the entire subnet, or even the entire VPC. And you can publish those flow logs to an S3 bucket, which you can then come in with something like SQL and on Athena and do a search through those flow logs, or you could use whatever your favorite log analyzer is. Skyline may have something. You can also publish the flow logs to CloudWatch if you want. Use CloudWatch mechanisms to search through those flow logs for any unexpected flows. And now, satisfying corporate IT, which can often be the most challenging part. If corporate IT comes to you and says, hey, we've got a real problem with your security system, don't be afraid to push back. Say, what is the purpose of your requirement? And are there other ways you might be able to mitigate that? Negotiate, They might say, oh, you've got to update your systems weekly, but you can say, well, okay, what if we update our systems quarterly? And I think it's also good to keep in mind defense in depth, right? By using multiple layers of security, you can ensure a single vulnerability or misconfiguration is not going to be exploited to cause significant damage. So, if there's a new 0-day that comes out, your first defense might be, well, my instance is in a private subnet, so it's not going to be exploited directly from the internet. Defense number 2, it's got a security group or firewall or network access control list that blocks that exploit port because I blocked that port because it's not part of my workflow. I blocked everything by default, so it's not going to get through. Defense number 3, that instance's IAM role is scoped to the least required access. So the only thing that this EC2 instance can do is read from an S3 bucket. Now, it still could reveal some data, but at least it's not going to necessarily blow up your entire system if it has the IAM role scoped down as tightly as possible. So, work with your IT team to balance updating and patching requirements with your workflow and production requirements while maintaining operational security. And thanks very much for your attention about this. The QR code goes directly to the security pillar of the AWS well-architected framework. And be safe out there.